Hello everyone, in this example we're going to do electron configuration for D groups, and we're going to explain the valence electron in D groups, and I'm going to tell you that some special cases that we have it, you have to be careful about them. Now let's take one of them. Let's say take titanium 22. So we're going to do this one, and we're expecting it to be 4. Is it what? It's going to be 4. I mean, this is what? This is D, yes? This is D2. Is it going to finish with 4D2? We're going to see this one, yes? As expectation, we know that it's in the 4, the group, it's 4. And since it's here, I mean, this is basically D2. I'm expecting it to finish as 4D2. Let's say, does it come in this way? Does it come in this way? So we're going to see those are D groups to see how does it look like. So we're going to take titanium, which is 22 electrons, and we're going to do the electron configuration to see how does it work. So we have Z to be 22, and we're going to go do the electron configuration. So we start with 1s, 2s, 2s, then we have 2p, 3s, 3p, and then 4s. Look, I was expecting to go for 4d, yes, I'm gonna go, and then after 4s we have 3d, then 4p, having something, yes, 5s, and after 5s we have 4d, but we have 22 elements here. Those 22 elements is gonna come to 4d. We'll see it now. So 2 here, 2 here, 6 here became 10. Well, 6, then 2, that became 20, and there's only 22. Wow, question mark. Okay, was expecting it to finish 4D, but it didn't finish with 4D, it finished with 3D. Wow, those are the D orbitals. They have these properties that they will not end up the way that we're reading for the normal groups, the main group they call them, the S group, the P groups. I mean, they're easy and they're predictable exactly by looking at them to know their electron configuration. However, D groups and F groups, they have a bit complication with the way that they're dealing with that, because when it goes higher, the energy levels basically are confusing. So that's why it's not going to end up with 4D. But still is D2, and we have still 4 inside the as a outermost shell, we have it there 4. So we know that the highest level basically is going to give it a period. Yes. So let's look at the things that are clear to understand. First thing is the highest level I have it is 4. The highest level is 4. So this 4 is basically going to give me the period number. This is going to give me the period number. We know that the highest level is going to give us the period number. The period number will be 4. We know it's in the 4th level. 4th row. The 4th row, we know that, because the highest level within this electron configuration is 4. This is the first thing we know. Now, for the group number, however, we're not going to look at this one. For the group number, we're going to look at the last one. This is where we're looking for the group number. The group number will be the last one. So we have D2, and we said that this is going to be useful to get the group number. So how do we get the group number here? We said that before D, there are 2 groups, S1, S2. So we simply, the 2 electron plus 2 groups before that. So we know that that's going to be group number 4. Because we said that before D groups, we have 2 more groups. So S1 is group 1, S2 is group 2, then D1 is group 3, D2 is group 4. So this is going to be group number will be 4, group 4. Well, the easiest way to know this one, just whenever you have D, just add 2 to the electrons in the D orbitals, then you're going to get the group number. For example, I will add 2 to this. It's already 2. 2 plus 2 will be 4, group number. If this was D5, I will add 2 electron, will be group number 7. That's easy way to find the group number in D orbitals. Then we know that D2 it's going to be, this is going to give us the name of the group. We call them transition metals. Transition metals. Now, come to the last property, which is valence electron. Well, which one is the outermost? I mean, D is the outermost shell we have it here, yes? But if you're looking at it, D is not filled as well. So D is not filled. Look, this is filled up to here. I mean, they normally filled. 3p6 is filled. Well, according to the rule, I mean, if you follow just the shell, what will happen? Before 4s, there's 3d, yes? I mean, the shell, if you're looking at the shell, 3 shells should be filled, then we can go to shell number 4. But we know that this is not going to happen due to the energy level. So basically, these two should be inside D, which is before inside D, and that time we would have said that the valence electron will be 2 plus 6 here plus 4 there, so it's a 12 valence electron. We have it. Well, however, within the literatures or within the books, basically they said that for those who are in the d orbital, we'll finish it with d orbital, you will take the last two part to tell the valence electron. However, there is different way to say that. Some people they say, okay, this is the way that we can say the valence electron here by taking those two, because this hasn't been filled. So it's something 4s came before 3d. So this is the valence electron is for titanium here. Well, some they said that if we checking the outermost shell is for s2, we can say even the valence electron is 2. Some they said that, well, since it's finished with 3, I mean 3 is the outermost shell we have it, or when the 3 hasn't even been filled, so they say, okay, 2, 6, 2, it's going to be 8 valence electron. Well, which one is most preferable? The way that it's taking those two basically, because those are, I mean, the outermost shell, and they haven't filled exactly, because D can take 10, so there are sometime one of them is going to come here. We're going to tell you that when it's happened, sometime one of these electrons is jumping back into D, so there will be reactive for chemical reactions. So for whenever we have D, we're taking the last two part, we're going to get the valence electron for those two. So 2 plus 2, we're going to say that valence electron will be 4. The valence electron will be 4. This is, we're going to use it for the d orbital. For the f orbital, it's going to be a bit more confusing, because there will be s, there will be d, there will be f, so it's going to take the 3 of them. We're normally just focusing on those for the students, so that the rest of them, I mean, if they're interested, they can go for further looking at them, because things are going to be more complicated in the level of f when it comes there. So this is how we're finding the valence electron, the group number, the period number, and the name of the group that we have it. Based on this, we'll be able to know that what will happen with those 4 electrons. Are they going to, are they going to take more, or is given, or is going to be sharing with the others in order to be stable, or what will happen to them? We're going to explain them in the bonding type when we start with them. Thanks for listening.